So now we're going to look at Kirchhoffs' laws. There's the first law and the second law, the junction rule and the loop rule. The junction rule is known as the current law. The loop rule is also known as the voltage law. So Kirchhoffs' current law simply states that if electrons are coming in, if a current is coming into a junction, the same amount of electrons will come out. So if I had 3 amps entering, I will have a total of 3 amps coming out, which is fine because 3 here, 2 plus 1 is also 3 coming out. Perfect. Same idea applies in all sorts of junctions. So we know that we can simply say the current coming in equals the current coming out. This is Kirchhoffs' current law in its simplest form. You have 0.5 coming in, 1.5 coming in, and then we also have 1.25 coming out and 0.75 coming out. These two are the same. This is 2 amps. This is 2 amps. Perfect. Okay. So the total coming in equal to the current coming out. It doesn't leak out, it doesn't stay, it all passes through. So the charge flowing in must equal to the charge flowing out. Conservation of charge. That's the principle this is. Conservation of charge, because it's charge that's moving. This is the most important part. Okay, just knowing that coming in equals coming out. The next one is the loop rule. We did many weeks of practice on this. We have loop rules. Remember, big line is positive, small line is negative, and we normally draw our loop from the positive to the negative. The current is flowing in this direction. So this is going from minus to plus. I am gaining 12 volts. This bulb uses it, so I can just put a little plus here and a minus just to show that I'm losing energy. I can do the same here. I am losing 3 volts here, and then I will lose 9 volts here. Simply meaning V gained equals V lost. Or you can rearrange it, which is what you most likely see. V gained minus V lost, and that always adds up to 0. For example, I have 12 from the battery, minus 3 from the bulb, minus 9 from this resistor. 12 minus 3 minus 9 is 0. Exactly 0. So around this loop, the gained voltage, 12 volts, is equal to the lost voltage. That's what it states here. So this is the conservation of energy principle. Conservation of energy, because it's the energy that's being given and the energy that's being used. I cannot lose more than I've been given. I cannot give more and lose less. As equal. They add up to each other. Very nice. So this is a quick summary. You can draw your loop in any way, really. I could draw the loop like this. I could draw the loop like that. You would get the same answer. One would just be negative. It just means the current would have been flowing in the opposite direction if you were to go ahead and solve. Okay, so we can use it. We tend to use from plus to minus. And I always add a plus and a minus to each component just to show me that I am losing it. Sometimes you will find that you will maybe have another loop and the cut maybe on the right hand side and the current flows this way. Because I already wrote the plus and the minus here, I have to keep the same notation. Even if it means technically I am gaining, if I was to follow the new loop that I made, I would have to do it just to keep the answers the same. Perhaps I will show you some examples of that in the next week's lessons. So here is an example. We have a current that reads 2 amps. We need to find I1. We need to find I2. And after that, we'll find the bottom battery voltage. So we'll use the loop rule to help us figure this out. We can simply draw a loop over here, and I can help me calculate I1. I can ignore the bottom part from now. I will ignore the bottom part. I will just look at the first loop. There are 2 loops. We will look at the first one only. Let me just erase this. So if you were to do that, we can simply do V1 plus V2 plus V3 equals 0. This and this and this equals 0 because there are only 3 things here. This is a gain. I am gaining 15, so this will be plus 15. I am losing energy here, so it'll be minus V. minus, I also know V equals IR, so instead of writing V, I can substitute not V, I can write IR instead. Minus again, because this is a resistor, that's also minus IR again. But just be careful, this is I1, this is I3 coming out. So this is R1, this can be R2, R3, it just doesn't matter, just make sure you remember your numbers, so which one's which. Perfect, equals 0. I can put the numbers in, pure math now, substitute. I already have 15, that's not a new number, that's 15. Minus I1, I don't know, so I will write I1. Multiplied by 7, I1 times 7, no problem. Minus this one over here, minus 2 times 5. Because I know the resistor is 5 and I have been told this is 2 amps. It says right here, 2 amps in the ammeter. So that means I have 2 amps flowing through this resistor over here. So we can simplify. I times 7 is just simply 7i. 2 times 5 is 10. I can do 15 minus 10, which is 5. 5 minus 7i is 0. Rearrange to get I. I'll take this across to the other side. It will become positive. And then I will divide 5 by 7. I will divide both sides by 7 to get rid of this 7 from here. 5 over 7 is 0.71. We have just calculated I1, 0.71. If you want to find I2, we can do that. We can calculate I2 very easily. We do know that this is 2 amps. We do know that this is 0.71 amps. I don't need to do a loop rule to figure out this one. I can, but no need. It will be challenging because we won't know I and we won't know this V. So we will use the current rule instead. The I in equals I out. I need 2 pieces of information to find the third. I do have 2 pieces of information, so I can find the third. I have I1, I have I3, easy. I can find I2. So this is easy to use if you have 2 pieces of information, 2 currents. I can find the third. I1 we agreed was 0.71 amps, we just calculated it. I2 we do not know, we're trying to find it because that's what it asked for. I3 I do know because it told me 2 amps. 0.71 plus I2 equals 2. So I can figure out I2, just do 2 minus 0.71, I will get I2, 1.29. I now know all 3 currents. I2 we figured out is 1.29. So finally, if you wanted to find the bottom battery voltage, same thing, loop rule. We will draw our loop from plus to the minus side. I'm gaining E. This is the voltage for E that's labeled, so I will write E. I will lose energy here, IR. Remember IR, this times this, IR. Minus the same thing we did previously, 5 times 2, which is over here, equals 0, because that is all there is. That is the only things here. So E minus this, this is minus 12.58. Once I've done that, I'll take it to the other side. It becomes 12.58. This EMF here, the battery here, is 12.58 volts. Next, there is another way. This is going to be a bit more complex. So this will be most likely for the grade 12 advanced students, but it is good to know for everyone else. First of all, if I have a multi-loop circuit, I can use Ohm's law if there is 1 battery. It gets more complex if you have 2 batteries. That's when you have to use the Kirchhoffs laws. So let's look at this using Ohm's law. If I wanted to find the current through each resistor, I have 3 currents. I have this current here, I1 maybe. I have I2 through here, and I3 through here. In order for me to figure out what the current through each one is, let's find the total resistance first. We're using Ohm's law here only. The total resistance, I realize I have this in series with these 2. It's parallel. 4 and 12, I will do 1 over 4 plus 1 over 12 minus 1, 3. It's always smaller than the smallest resistor, so 3 looks about right. So this is a total of 3 ohms. I can find the total resistance altogether now. This 3 ohms, this was 3 ohms together, plus this 3 ohms, which is 6 ohms. V over R, 24 over 6, 4 amps. The total current flowing through here is 4 amps, which means R1 will have all 4 amps. We have just calculated I1 already. Done. This is the first one done. Next, I need to know, well, before we can figure out the current here, I should know the voltage here and here. It is being shared. I have 12 volts. This is some, and this is some. You can probably figure out if this is 3 ohms and this is 3 ohms, it will be half and half, so 12 volts and 12 volts. Or you can just check by using V equals IR. The V, which is what we're trying to find, is I, the total current flowing in and out. The total current was 4 amps multiplied by the parallel resistance, which was 3. 4 times 3 is 12. So we were right. It is 12 volts here. Now that I know that we have 12 volts here across these two, I can calculate the current here and I can calculate the current here. V over R. 12 over 4, 12 over 12. 12 over 4 is 3 amps, 12 over 12 is 1 amp. 4, 3, 1. Does that make sense? Well, it should, because I have 4 amps entering the junction. I have 3 going this way and 1 going this way. 3 plus 1 equals 4. So we are correct.